Hi, Caden. I want to respond to your question about what do you do with the Dalton's Law problems that are on page 164. This is so much more complicated than what it really is that you'll be shocked. And basically what we're dealing with is Dalton's Law, which if I get the pen to work says that P total equals P of gas 1 plus P of gas 2, given that P equals the pressure. So the first problem I would like to go through, and I think in doing that, you'll get a sense for really how easy this is. Oxygen gas was produced by the decomposition of potassium chlorate and collected by water displacement, which means that what we have done, here's my pan, and here's my water level. Here I'll make the pan a little bit more three-dimensional, and I'll put my graduated cylinder down under the water. And I will be somehow decomposing potassium chlorate, and there's a stopper in here, and we'll color in the stopper, and a tube which goes down underneath the water and up into my graduated cylinder. Here I'll mark it so you know it's graduated cylinder. And what's happening, and there's gas bubbling up into this space. Here's my gas. So there's potassium chlorate, and we'll draw another arrow, in here. It's decomposing, and it is creating oxygen gas. We are displacing water that is in our graduated cylinder here and collecting it over water. In 2 hours, we have collected 350 mils of oxygen gas, and the temperature is 24 degrees centigrade, and the pressure is 760 torr. The question is, what is the partial pressure of O2? Let me go through all the data that they've given you, cross out what we don't need. We don't have anything that tells us what to do with time, so we're going to cross that out to begin with. Now, our gas laws do have something to do with volume and temperature and pressure. Dalton's law, however, and this is what this section is entitled, really has only to do with pressure. So the volume is really not significant in this case. The temperature is important because we need to know vapor pressure. And I just realized this may be why you can't do this problem, because you need the vapor pressure table, and I think I've included that on the left sidebar of the homework assignment. You don't have the information in your book that I have in my book that says the vapor pressure of water is 22.4 torr at 24 degrees. There is a chart that tells you vapor pressure, and I think I've included it in the navigation of the web page. If not, I will send it to you on email. So that is what this information relates to. The temperature relates to. The water pressure, vapor pressure due to water is 22.4 torr at 24 degrees. So now all we do is plug in Dalton's equation. 760 torr is my total, so we say 760 torr equals X minus, and the vapor pressure due to water is our pressure due to gas number 2, which is 22.4 torr X, which must be the vapor pressure due to the oxygen, since pressure gas 1 plus pressure gas 2 equals pressure total. X would equal 760 minus 22.4 torr, which is 7.4 times 10 to the 2 torr, which you can convert to atmospheres if you want. You can convert the pressure to atmospheres at any point in this. It doesn't matter. The key to all of this is having this information available in a chart that tells you what the vapor pressure of water is at every temperature that these problems involve. I forgot that my book, which is an older version, includes that in each problem, and the newer books don't. And that's probably exactly where you're getting stuck. You're right. You can't do it without that information. So I'm hoping this will solve the problem.